This video is for section 1.1, 1.2, and 1.3. We're going to start with section 1.1, which is really just an introduction to what statistics is. Statistics involves collecting, classifying, summarizing, organizing, analyzing, and interpreting numerical information. So that's what we're going to be doing in this class. In statistics, we deal with data. Data are values along with their context. Usually they're going to be numerical values, but not always. And the context is important to keep in mind when we're working with data. A really common use of statistics in the business world is looking at transactional data, where businesses look at who is buying products, what products they're buying, when they're buying them, where they're buying them, and they use this information to make decisions about what they're going to do in the future, where they need to send more products, where they need to send fewer products. All of those kinds of decisions are based on statistics. So when we're looking at data, we want to keep in mind the 5 W's: who, what, when, where, and why. This is the context of the data. And often we add how to the list as well. We want to keep in mind how the data was collected. So we often have a data table like this one. The rows of the data table correspond to individual cases about whom we record some statistics. So these are the cases. For this problem, the cases are different orders, and that tells us the who. Now, if we have a survey, individuals who answer a survey, then our cases are going to be called respondents. If we're doing an experiment, then we can call our cases subjects or participants. If they are inanimate objects, websites, things like that, we would call them experimental units. So for this table, we would call our cases experimental units because they are orders. They're not people, although each one is made by a person. The cases themselves are inanimate objects. So what we record about each case is given in the columns, and that gives us the what. These are called the variables. So that's the what of my data set. So we're going to look at this example with Carly. She's a marketing manager at a credit card bank, and she wants to know if an offer mailed 3 months ago has affected customers' use of their cards. So she assembles this data for different customers, and this is the spreadsheet that she gets. So we want to identify the cases and the variables and describe the W's for this data set. So my cases is going to be the who. In this case, that's going to be customers. Now, they're not identified here by name, they're identified by an account ID number, but each account number goes with a specific customer. The variables are basically going to be all of the different columns that I have in this table. So account ID number, the pre-spending, the spending, the age of the customer, the segment, whether or not they enrolled, the offer that they received, and the segment spend. So in terms of the W's, the cases are going to be the who, and the variables are going to be the what. Now, when and where, sometimes they are given and sometimes they are not. So in this case, all the problem says about when is it says that the data was recorded 3 months before the offer was sent and 3 months after the offer was sent. It doesn't say a specific date or a specific year or anything like that. So I'll just say 3 months before and after offer was sent. Now for where, in this problem, it doesn't say anything specific about location. It's a credit card. It could be anywhere in the country. It could be in a different country. I don't have any information about where the customers actually live. So I'll just say that this is not given. And lastly, we have why. So the why is really the question that we want to answer by collecting the data. So if we go back up here, we see that Carly wants to know if the offer has affected customers' use of their cards. So that's the why. Did the offer affect customers' use of the card? So those are the 5 W's. Next, we're going to look at some different variable types. And the first way we're going to categorize variables is into 2 types. We have categorical variables and quantitative variables. Categorical variables are responses to questions where the response is a word. So it could be a yes or no, or it could be a question where you're saying you agree, strongly disagree, slightly disagree, freshman, sophomore, junior, senior, anything where the answer is a word. It could also be a number like a zip code. Now, you have to be careful because generally quantitative variables are going to be numbers, but not always. So with a quantitative variable, you have to have a unit. Something like a zip code is a number, but it doesn't have a unit. There are no units to a zip code. So a zip code is not a quantitative variable. So what we're going to do first is classify these as categorical or quantitative. So the first one is the number of touchdowns in a football game. So it would be something like 3 touchdowns or 5 touchdowns. Touchdowns would be the unit, so that's quantitative. Highest level of education that a person has attained, so that would be like a high school diploma, associate's degree, bachelor's degree, those are categories. Makes of cars sold by a particular car dealer, so something like Ford, Jeep, Lexus, those are also categories. Number of cars sold by a car dealer last month, so that would be like 100 cars or 200 cars, those are numbers. Cars would be the unit, so that's quantitative. And height of a person could be something like 6 feet or 65 inches. Those are quantities. They have a unit, feet or inches, so that's quantitative data. Now, you have to kind of be careful because sometimes it depends on how we're collecting the data. So for example, age, if we're just collecting the numerical age, if somebody's 30 years old, then we would say that that's quantitative, but we can also collect age in a categorical way. If we use ranges like child, teen, adult, or senior, then that would be categorical. And then we have another type called an identifier variable. This would be something like a social security number, a student ID number, tracking numbers, transaction number, customer number, product ID number. Those are all examples of identifier variables. They're often numbers, but they don't have units, so they are categorical. And we can't really analyze them. They just identify a particular case or a particular product. Categorical variables, we can classify them further as nominal or ordinal. So nominal means it names a category, and ordinal means that the categories can be ranked in order. So there's an inherent order in the situation. So we're going to classify these as quantitative or categorical and then state whether they are nominal or ordinal. So we'll start with nationality. That would be things like French, British, Italian. Those are categories, and there's no inherent order there. None are better than the other, so that would be nominal. Number of siblings could be 2 siblings, 3 siblings. Those are numbers. Siblings is the unit, so quantitative. Hair color, blonde, brown, black. Those are categories, and there's no order to them, so that's nominal. Height of rides at an amusement park, probably measured in feet, maybe yards, so that would be quantitative. College major, business, engineering, marketing, economics, those are all categories, and there is no order there, so that would be nominal. Letter grade in a class. Now, these are categories, A, B, C, D, but there is an inherent order. A is a higher grade than a B, B is a higher grade than a C, so that would be an ordinal variable. Weight of a randomly selected dog, that would be quantitative. In pounds, probably. Method of payment, check, cash, credit card, those are categories, and there is no order there, so that would be nominal. Marital status, single, married, engaged, divorced, those are all categories, and there is no ranking or order to that, so they would be nominal. Grams of fat in a donut, measured in grams, it would be a number, that's quantitative. Rank of a military officer, so that would be categories, it would be like lieutenant, colonel, general, but there is an order because some ranks are higher than others, so that would be ordinal. And lastly, population of a state would be a number of people, and so that would be quantitative. So one last way that we're going to look at classifying variables is time series and cross-sectional. Time series means that each case is measured in a different period of time, and cross-sectional means that all cases are measured at the same time. So now we're going to classify the chart that we saw earlier from the credit card bank. Quantitative or categorical. If it's quantitative, what are the units? If it's categorical, is it nominal, ordinal, or identifier? Account ID, this is an identifier variable. It identifies the account, so it's categorical, and ID is right in the name, identifier. Pre-spending, that's a dollar amount, it's quantitative. Post-spending is a dollar amount, and it's quantitative. Now you have to be careful here with age, because in this situation, the age is written in a range. So that makes it categorical, not quantitative, because it's not a single number. But it is ordinal because we can put them in order. We know that somebody who's less than 25 is younger than somebody who's 35 to 44, etc. Segment would be categorical and nominal. There's no order there. Enroll, yes or no answer, is categorical and nominal. The offer they received, none, gift card, those are nominal, categorical. The segment spend is another dollar amount, so that's quantitative. And the last question is, are the data time series or cross-sectional? Now each case here was measured at the same time, so that makes it cross-sectional. So next we're going to look quickly at section 1.3. This is about how we collect data. We can collect data by performing an experiment, or we can find data that's already been collected by somebody else. Carly's data was transactional data, so she got the data from the company itself. She didn't ask people about what they were spending. But if she asked her colleague to email a sample of customers and ask about their card use and household demographics, that would be called a design survey. She didn't ask them to do anything, she just asked them about what they normally did. Greg designs a study where he gives people different offers and then tries to see how much they spent. So he's actively manipulating the situation. This makes it a designed experiment because he is trying to give people certain offers and saying, okay, well, I think if they get a better offer, then they might spend more. So the difference between an experiment and a survey is whether or not you're doing anything to manipulate the situation or if you're just asking people about what they normally do. So if you're asking people about what they normally do, that's a survey. If you're trying to get people to do something out of the ordinary, then that's an experiment.